Welcome to episode 14 of the podcast, The Tech Lounge, where today we are discussing scaling the harness in agentic AI. And to kick things off, I want you to imagine for a second that you just hired like a world-class genius. I mean, a once-in-a-generation, off-the-charts mind capable of synthesizing massive amounts of information in literally seconds.
I mean, yeah, that sounds like the kind of hire that basically makes or breaks a company, right?
Right. But there's a massive catch here. This genius has severe, 50 First Dates level amnesia. Every single time they finish a thought, their memory just totally resets. And, immediately upon hiring them, you lock them in an empty, windowless room without a laptop, no notebook, not even a pen.
Oh, wow. Okay, so they are brilliant, obviously, but fundamentally paralyzed. Like, they just can't interact with the real world at all.
Exactly. You could slide a complex riddle under the door, and they'd slide the perfect answer back out a minute later. But if you ask them to actually build a spreadsheet or organize a project or write a piece of software over the course of a week, they would fail completely. And, that scenario perfectly describes what it's like having a massive state-of-the-art AI language model right now. If it doesn't have this meticulously engineered system built around it, it is really just a brain in a jar.
Yeah, which is the exact bottleneck the entire industry is hitting right now. I mean, we've kind of hit a wall.
Yeah, we really have. So welcome to the deep dive. If you're joining us after a long week of work, grab a drink, settle in, because today our mission is to uncover why making AI models bigger and smarter just isn't enough anymore. We're unpacking a pretty fascinating stack of technical papers, industry blueprints, and architectural breakdowns focused entirely on this concept called harness engineering. We're looking at how building the right harness around a model is the absolute secret to creating reliable, autonomous digital coworkers.
And honestly, the timing on this is crucial. Because for the past couple of years, the dominant narrative in tech has been strictly about model scaling. Like, the assumption was always that if we just throw more compute at the problem...
Buy more GPUs, right?
Exactly. Buy more GPUs, add a few trillion more parameters, and feed the model more data, it will, magically learn how to do all our jobs for us.
Right, the whole raw horsepower argument, like, just build a bigger engine.
Yeah, but right off the bat, that feels deeply flawed. Out of the box, an AI model is ultimately just doing next token prediction. It's hyper-advanced autocomplete. It predicts the next word based on probability, but it has no persistent state. It has no tools to look up current data, and it certainly has no intrinsic way to coordinate a multi-step project over 3 days.
Right, which brings us to the core formula.
Yeah, exactly. This is where we arrive at the core formula driving the next generation of AI development, which is agent equals model plus harness.
Agent equals model plus harness. Got it.
Right. So the model provides the raw intelligence and the reasoning capability. But the harness is, well, it's everything else. It is the code, the configuration, the memory systems, and the execution logic that actually turns that raw reasoning engine into an active, useful worker.
So, if I can try to visualize this for anyone listening, having a massive language model without a harness is kind of like having a 1,000 horsepower Formula One engine just sitting on a concrete garage floor.
Oh, that's a great way to put it.
Right, like you can turn it on, it will roar, it will burn fuel, but it isn't going anywhere. The harness is the chassis. It's the transmission, the steering wheel, the fuel lines, and the brakes. Without those components, the engine is literally just a really noisy paperweight.
That analogy holds up perfectly, especially, when you think about the brakes part. The overarching philosophy here is that if you are not the model, you are the harness. We are transitioning away from trying to make the AI intrinsically understand everything on its own toward building systems that carefully manage how the AI interacts with the digital world.
Because historically, right, we harnessed animals for that.
Yeah, exactly. Think about how farmers historically harnessed animals to do steady, repeatable work. The animal has the raw power, but the harness directs it safely. Now, we must do the exact same thing with AI to spare humans from repetitive digital labor, allowing these systems to handle long-horizon tasks. Things that take hours or even days to complete.
Okay, so let's actually pop the hood on this chassis. I really want to look at the anatomy of a harness, because knowing we need to hook the engine up to a transmission is one thing, but what does that actually look like in code? Like if we were turning our amnesiac genius into a functional employee, what specific tools are we sliding under that door?
Well, the absolute foundation of any functional harness is a file system. You really have to give the AI a persistent workspace.
Oh, because, the model itself only lives in the present moment, right?
Yeah.
It's totally confined to whatever text is currently sitting in its context window.
Precisely. A language model just can't hold a 10 gigabyte corporate database in its immediate context window. It would completely overload. So the harness steps in and provides a durable place for the AI to read data, store intermediate thoughts, and, persist its work across sessions.
Like giving it a hard drive.
Yeah, think of it as giving the AI a combination of a RAM scratchpad for quick immediate notes and a hard drive for long-term storage.
And what happens if the system crashes?
That's the best part. If the entire system needs to reboot for maintenance, the AI doesn't have to start from zero. It wakes up, the harness feeds it the transaction logs from the file system, and the AI basically says, oh, I see I was on step 4 of the data migration, and it just resumes perfectly.
Okay, so that completely solves the amnesia problem.
Yeah.
What about the action problem? Because an employee with a filing cabinet is great, but they still need to do actual work. Historically, it felt like programmers had to manually write specific tools for the AI, like here's a Python script that checks the weather, or here's a script that queries a database.
Right, the old plugin model.
Yeah, the AI could only do what we explicitly pre-programmed it to do. It felt very rigid.
And that approach just doesn't scale. You simply cannot anticipate every novel problem an AI is going to face in a dynamic work environment. The modern harness takes a radically different approach. It gives the AI general-purpose tools, and the most prominent example of this is giving the AI a bash shell, essentially a full command line interface.
Wait, I need to stop you right there. Giving an AI a command line interface means it can write and execute its own code on the fly to solve whatever problem it encounters.
It does. It absolutely does.
But I mean, if I let a random script run wild in my own computer's command line, I'd probably corrupt my operating system in like 5 minutes.
We're talking about giving a non-deterministic AI the power to write arbitrary software and just run it. How is this not an immediate sci-fi movie disaster waiting to happen?
Yeah, the security risk is massive, which is why the harness never ever lets the AI touch a live production server directly. What's fascinating here is how the harness utilizes sandboxing to solve this exact problem. Sandboxing. So we were basically building a containment field.
A highly restricted containment field, yeah. The harness spins up an ephemeral, completely isolated environment, usually something like a secure Docker container where the AI can safely run the code it just wrote. It is totally walled off from your actual business data or the broader internet unless you explicitly give it permission.
Oh, I see. So the AI writes a script to, say, sort of database. The harness takes that script, drops it into this temporary sandbox, runs it against dummy data, and just sees what happens.
Exactly. And that creates what we call a self-verification loop. The AI runs the code in the sandbox. The code inevitably fails on the first try because, let's be honest, programming is hard.
Right. There's always a missing comma or something.
Always. So the sandbox generates an error log. The harness then feeds that error log back to the AI. The AI reads it, realizes it missed a semicolon or misunderstood an API endpoint, rewrites the code, and tries again. The harness is acting as this impartial referee, enforcing hard-coded guardrails and recording every single attempt.
Wow. Okay, I see the brilliance there. The AI is no longer a black box just spitting out an answer. You actually have a fully auditable trail of its thought process, its mistakes, and its corrections, all happening in a room where it can't accidentally delete the company's payroll database.
Precisely. It's safe trial and error.
Okay, let's unpack this a bit more because this introduces a completely new bottleneck. Action creates noise. If this AI is running around inside its sandbox, writing code, executing scripts, generating error logs, taking notes in its file system, it is going to generate an absolute mountain of text.
Oh yeah, terabytes of it eventually.
Right, so if you're listening to this while sitting at your desk, think about how you feel when you have 50 browser tabs open across 3 different windows, Slack is pinging, and your email is open. Eventually your brain just freezes, you can't find the tab playing the music, you lose your train of thought, and you just have to close everything and start over. How does an AI not suffer from that exact same cognitive overload?
That is a phenomenal comparison, honestly, because it perfectly describes what engineers actually call context rot.
Context rot. That sounds, yeah, the gradual decay of focus. I assume the initial sort of naive solution to this was just to build models with larger context windows.
Yeah, that was the industry's reflex for a long time. The thought process was literally just, if the AI is forgetting things, we just need a 1,000,000 token context window, let it read an entire library all at once. But expanding capacity really does not solve the underlying cognitive issue. In fact, flooding a model with massive unfiltered inputs actually causes signal dilution.
Signal dilution, meaning What, the AI has the information technically available in its memory, but the actual signal is just drowned out by the noise of everything else.
Exactly. It is exposure without access. You might feed the AI a 100-page document, but the single crucial variable it actually needs is buried in paragraph 4000. Because it is so overwhelmed by padding and boilerplate text and completely irrelevant logs, the attention mechanism of the model just completely glosses over it. Long context absolutely does not guarantee good context.
Yeah, I mean, if I have 50 tabs open, giving me a wider monitor doesn't actually help me find the right tab. It just gives me way more space to be disorganized. So how does the harness step in and fix context rot mechanically?
So the harness acts as a ruthless executive assistant using a technique called compaction. Because the hard problem of context isn't about how much data you can store, it's about governance. The harness literally dictates what the model is allowed to focus on at any given second.
Walk me through the mechanics of that compaction. Does the harness just go in and delete old memories?
Not delete, it compresses them. So when an agent's internal monologue or dialogue history hits a certain length threshold, the harness temporarily pauses the main task. It takes the older portions of the conversation, runs them through a really tight summarization process, and replaces the massive block of raw text with a dense, highly accurate summary.
I see a risk there, though. If the harness summarizes an older conversation, doesn't it run the risk of hallucinating the summary or leaving out some tiny detail that suddenly becomes critical 3 days later?
That is a very legitimate risk, which is exactly why modern compaction isn't just a simple text summary. The harness often takes that raw data and embeds it into a vector database.
A vector database?
Yeah, it's basically a searchable mathematical representation of the text. So it stores the full raw text there safely, while only keeping the high-level summary in the AI's active context window. If the AI suddenly needs that obscure detail from 3 days ago, it can just use one of its tools to query the vector database and retrieve the exact raw text.
Oh, that's smart. So it's basically keep the main thing, but leave a breadcrumb trail back to the archives just in case.
Exactly. And there is another crucial technique here called tool call offloading. Let's go back to our sandbox example for a second. The AI runs a script, and it fails spectacularly, generating a massive cascading server error log that is like 50 pages of pure, dense text.
Yeah, if you feed those 50 pages directly into the AI's active context, it will instantly suffer from context rot. It will just lose its train of thought entirely.
Right. So the harness intervenes. It takes that massive error log and saves it directly to the local disk. Then, it only feeds the AI an 8-kilobyte preview. Basically just the top few dozen lines of the file.
Wait, that forces the AI to behave exactly like a human software developer. When my code crashes and spits out a mile-long error trace, I don't read the whole thing. I look at the top 5 lines to see what module failed, and I only dig deeper into the log if I really need to track down a specific variable.
Yeah.
The harness is basically enforcing human-like attention management.
Exactly. It optimizes for minimum sufficient context.
Okay, that brings up a broader question about how these models handle memory over time.
Yeah.
Because we've established that the file system gives the AI a persistent workspace. It can leave notes for itself. But human memory is notoriously flawed, right?
Right.
Because the world changes while our memories stay the exact same.
You are touching on one of the most dangerous vulnerabilities in autonomous systems right now, the stale but confident threat.
Stale but confident.
Yeah. To understand why this is so dangerous, we really have to look at semantic memory. Semantic memory is your broad conceptual understanding of the world. It's knowing that birds fly, or in an IT context, knowing that the company's master database is located in a specific AWS bucket. But semantic memory often lacks episodic context. It doesn't inherently remember when or under what specific conditions that fact was established.
Oh, I see. So an AI agent is working on a complex software architecture project. It figures out where the master configuration file is, and it writes a note to its persistent semantic memory. The master config file is located in folder A.
Right. And then a week passes. During that time, a human engineering team comes in and decides to refactor the entire codebase. They move the master config file to folder B and just totally delete folder A.
So the AI wakes up the next morning to run an update. It checks its semantic memory, sees config file is in folder A, and confidently executes a script to overwrite it. But folder A doesn't exist anymore, or worse, it has been repurposed for something else entirely. Because the AI is highly confident in its own internal notes, it breaks the entire application.
Exactly the problem. The hard problem of agent memory isn't storage capacity, it is trust. If an agent blindly trusts its own historical notes, it becomes a massive liability in a dynamic environment.
So how does the harness fix a stale but confident AI?
By enforcing a framework called skeptical memory. Programmatically, the harness treats all of the AI's internal notes and semantic memory strictly as unverified hints.
Like, trust but verify.
Precisely. The AI might pull up its note saying the file is in folder A, but before the harness allows the AI to execute any destructive or altering code based on that note, it actually forces the AI to run a quick observation command against the live environment. Basically, check if folder A still contains the config file before you touch it.
Wow, we are literally engineering skepticism into the workflow. The raw model just wants to generate the next token and take action. But the harness is kind of like the little voice in its head saying, hold on, the world might have changed since you last looked. Double check your assumptions.
Yeah, and during idle periods, advanced harnesses will actually run background hygiene routines. They will scan the AI's memory files, look for contradictions, test links to see if they are dead, and resolve outdated information so the agent's baseline knowledge doesn't just degrade into a mess of broken facts over time.
Incredible. So we have a completely perfectly governed, highly efficient single worker. It has a persistent workspace. It writes and tests its own tools in a secure sandbox. Its context is aggressively managed so it doesn't get overwhelmed, and it constantly double-checks its own memory so it doesn't confidently break things.
Sounds like the perfect employee.
It does. But a single, perfectly governed worker still hits a hard ceiling, because complex, real-world work requires parallel processing. This kind of forces us to figure out how these walled-off, sandboxed agents can actually talk to each other. Like, how do we scale from one amnesiac genius to an entire corporate department of them?
And this is the ultimate frontier of harness engineering, scaling to the system. To make an AI a true coworker, you just cannot leave it isolated. You need an infrastructure that mimics the structure of a human organization. And the blueprints we are analyzing break this down to 5 distinct, necessary layers.
Okay, let's ground this a bit. Say I want a team of agents to research a competitor, write a financial analysis, and then build a web dashboard to present the data. Walk me through how multiple agents use these 5 layers to actually collaborate without just stepping all over each other's toes.
Sure. So the first layer is communication. And this isn't just agents casually chatting. It's a structured broadcast layer. Agent A, who is the researcher, needs to be able to send a message to Agent B, the coder, saying, I have the data ready. This requires standardized messaging protocols baked right into the harness so agents can accurately parse each other's intents.
Like internal system APIs, basically. Okay, what's the second layer?
The second is shared knowledge. If Agent A spends 3 hours figuring out the competitor's pricing structure, Agent B shouldn't have to start from scratch to understand it. The harness maintains a centralized, instantly accessible knowledge graph that all authorized agents can query at any time.
Makes total sense. Don't duplicate work. Third layer.
Third is execution, which is essentially the handoff layer. Agent A finishes the research report and then formally passes the baton to Agent B to build the dashboard. But what's cool is it also includes fallback mechanisms. If Agent B hits a wall and just can't figure out a coding bug, the execution layer allows it to tag in a third agency, who specializes entirely in debugging to review the code.
Wait, they can escalate problems to specialists? That is wild.
It's totally autonomous routing. Then the fourth layer is transactions. This is the reasoning audit trail. Every single time an agent makes a decision, passes a baton, or alters a file, it is logged immutably.
And I'm guessing the fifth is the actual output?
Yep, the fifth is work products, the actual final output. So the code repository, the drafted plan, the validated financials.
Here's where it gets really interesting, though, because I have to push back here. If these agents are passing tasks back and forth in their own closed digital ecosystem, operating at the literal speed of compute, how do we know they aren't just simulating productivity or getting stuck in endless loops of middle management bureaucracy, like Agent A asks Agent B for data, Agent B asks Agent C for permission, Agent C throws an error back to Agent A. I mean, they could sit there looping for an hour, burning through massive amounts of computing power while accomplishing absolutely nothing.
Yeah, that happens constantly in poorly designed systems. And it is exactly why the way we evaluate AI has to fundamentally change. In the era of simple chatbots, we evaluated models based on one-shot outcomes.
Right, like, did it answer the question correctly, yes or no?
Precisely. If the final answer was correct, we just declared the AI a success and moved on. But in multi-agent systems, one-shot outcomes hide massive systemic liabilities.
Because it completely ignores the cost of getting to that outcome.
Exactly. Let's look at the API problem as an example. Say an agent needs to pull data from a paid external service. The agent writes a script, but the script has a bug. Instead of cleanly pulling the data, the agent gets stuck in a loop and basically brute forces the solution by pinging that paid API 10,000 times in a single minute.
Oh man. He gets rate limited by the API provider, or worse, it racks up a $10,000 cloud computing bill before anyone even notices. It technically finished the task, so the one-shot outcome is technically a success, but the process itself was a catastrophic failure.
Which is why the transaction layer of the harness evaluates something called trajectory hygiene.
Trajectory hygiene, basically measuring the cleanliness of the path taken.
Yes. If we connect this to the bigger picture, the harness monitors the efficiency of the agents in real time. Did they verify things properly? Did they use their context window cleanly without generating unnecessary noise? Did they resolve an error in 3 steps? Or 300 steps? The transaction layer tracks every single micro step. Because everything is transparent and auditable, the harness can step in and strictly enforce limits. If an agent starts spinning out of control and hammering an external server, the harness recognizes the poor trajectory hygiene and instantly revokes its execution privileges.
Wow, so it's an active programmatic supervisor just sitting above the agents, ensuring they don't bankrupt the company or burn down the servers. You know, that brings up the final massive hurdle for deploying this in the real world: security and data sovereignty. Because if I'm a defense contractor analyzing classified schematics, or I don't know, a hospital network processing patient health records, I cannot send all of this internal multi-agent chatter out to a public cloud server run by a massive tech company. I mean, the compliance violations alone would be staggering.
Yeah, data sovereignty is a hard blocker for enterprise adoption right now, which is why the rising maturity of open weight models is the absolute linchpin for this entire architecture.
Let's define that mechanically for a moment, just so we're clear. Open weight models are AI models, where the core mathematical weights, like the actual trained brain structure, are made publicly available to download. They might still have proprietary licenses attached to them, but you physically possess the model files on your own hardware.
Right. And by downloading those open weight models, a hospital or a defense agency can run the entire multi-agent system completely locally on their own on-premises servers. You aren't pinging an external API to do the reasoning. The data literally never leaves your building.
You own the intelligence.
You keep your AI truly sovereign. It operates entirely within your own data center, completely air-gapped from the internet if necessary, wrapped in this incredibly secure, sandboxed harness we've been discussing. And because of that, it can meet the strictest compliance frameworks hyped to healthcare or FedRAMP in the defense sector, because the reasoning engine and the data are physically locked inside your walls.
Okay, so you get the team of genius digital employees, but they work exclusively in your secure basement, and the doors are locked from the outside.
That's one way to picture it, yeah.
Taking a step back and looking at the entire landscape we've mapped out today. So what does this all mean for you, the listener, navigating this transition in the real world?
I think the most profound takeaway is that we have to fundamentally shift how we judge the value of AI. We spend so much time on social media and tech blogs arguing about which underlying model is slightly smarter. You know, which one scored 2 points higher on a standardized math test, or which one has the most parameters.
Yeah, and the raw capability of the model is still an indispensable baseline, obviously, but it is no longer the sole predictor of the system's actual success.
Exactly. As AI moves out of the chat window and becomes a fully integrated digital coworker operating in the background of our businesses, understanding the harness is just as important as knowing which LLM you are using. The rules of engagement, the memory governance, the sandboxing, the trajectory hygiene, that is where the actual productivity is generated. We are officially moving from a paradigm of scaling models to a paradigm of scaling entire systems.
Which leaves us with a highly provocative thought to end on.
Lay it on me. We are putting massive amounts of engineering into the harness right now. We are building these intricate multi-layered infrastructures for durable memory, secure sandboxes, context compaction, and autonomous skill routing. The harness is really doing the heavy lifting of keeping the AI sane, productive, and secure.
Right, it is doing all the actual management.
So at what point does the harness become more valuable than the AI model itself?
Oh, That is a fascinating flip in perspective.
Right. As these foundational open-weight models get cheaper, faster, and more ubiquitous, their raw intelligence is essentially becoming a utility. It is becoming commoditized, much like electricity or internet bandwidth. If any company in the world can easily download a genius-level reasoning engine for free, then the model itself is no longer your competitive advantage. What happens to the tech industry when the underlying AI is totally commoditized and all the actual proprietary magic resides entirely in the scaffolding?
The system that tells the amnesiac genius what to do, hands them the tools, filters their noise, and rigorously checks their work. You might have the smartest brain in the jar, but if my jar has better wiring, superior memory management, and cleaner trajectory hygiene, my digital employee outcompetes yours every single time.
Precisely.
That is a wild concept to ponder as these systems start rolling out into our daily workflows. Well, thank you all for joining us on this deep dive. Stay curious, watch out for context rot in your own browser tabs, and we will catch you on the next one.